Hello again, it's that castle guy again. Today, we're going to talk about the core building elements of level design. The core archetypes that we mix and match to do all the different things in the world of 3D gaming. This applies to either first or third person games, both small and large. One of the main things that has caught my attention lately has been the development and workflow around voxels. Voxels, this can be for the vast under-ocean landscapes of Subnautica, or the tightly designed world spaces found in Cube or Tesseract. So with that said, how do voxels fit in the world of level design when comparing them to other development methods? Well, for starters, we should break down the core methods of design from one side of the spectrum to the other. I'm going to start with the very common and most simplistic medium, and that is the terrain mesh. This medium is ultra simple and is used super often. There are literally hundreds of ways to go about creating and storing terrains in the world, so I don't even have to go into much detail about them. It's variable height geometry that allows you to usually paint mountains and valleys and everything in between. It doesn't really need to get much more detailed than that. Next is most rarely seen by the public level design community. I call it contiguous level design. This method of level design is rarely seen by communities because it pretty much requires you to have a third-party modeling tool such as Max or Maya. That is a huge upfront cost for the normal person to begin to learn the ins and outs of level design. These programs are complex and bloated, and they force you to understand a lot about how the engine works before you can even begin to build things effectively. Engines that require you to build contiguous level designs tend to also force you to have much more detailed understanding of occlusion culling, simple collision, advanced UV unwrapping, light map densities, and everything. Now, don't get me wrong, these are all things that are helpful to understand when building in non-contiguous environments. But let's be honest, you can build a pretty cool and fun Quake 3 map with very little understanding of the above things. Occlusion culling is automated within the compile process, provided you keep your BSP clean with detail brushes. Even though you will likely place clipping or blocking volumes, you may never need to really understand what it's like to literally simplify every square inch of your level. You may not even know what a UVW unwrap is, even after building levels professionally for years. Light map densities are mostly automated when it comes to brushes, so it's very possible to build a good level without fully understanding that either. And if the engine you are working with doesn't even use light mapping, then you're a pirate and there be lighting in these parts. With contiguous design, however, you really want to have a proper understanding of how the engine handles all these things right away. Regardless, I always say it's better to know as much as possible about the engine you're designing for, even if it's not required. Anyway, when it comes to contiguous level design, you can very safely expect all aspects of the design process to be manual. Even with some of the best tools, it's really not that outlandish. Occlusion culling will likely require you to manually break the level up into chunks and then place volumes around them. Bonus points if the tools expect you to manually state what volumes can see into what other volumes by hand. All simple collision based around the geometry you create is your responsibility. It's your clip brushes and on hard mode. Why do I say that? Well, when calculating collision on a 3D mesh, the engine has to traverse the entire mesh in order to calculate a collision. You notice the performance loss with stuff like this a lot less when working with brushes, but the contiguous design, that whole area just might be built as one object. One giant, concave, curvy, detailed computational disaster. Scientists in white lab coats run screaming in terror at what you can belch out in under an hour. They will run until they get stuck on something. You might be proud, but ultimately, all you did was kill math, and math cannot be dead in a game you want people to play. Light maps require you to manually break up meshes. Then make sure they don't have overlapping UV space on their unwrap. You'll have to find yourself, you will find yourself being concerned about light map density very often, if not all the time. And if there are no forms of baked lighting, then there be lighting in these parts. Pirate. This doesn't even include all the stuff that comes with understanding the modeling package itself. These things are a world of junk just by themselves. So you might be thinking, why would anyone subject themselves to this style of design? Well, for starters, it's total power over everything in a way that's hard to replicate. You really seriously do have control over everything in a very straightforward manner with this style of development. Want to know the really fun part? From what I know, this style of design is more common than any other. When you look across the game industry, it's true. In the level design community, it's rare to see any proponents of contiguous level design. It's a completely different world to what most of us from any mapping community have ever seen, or have seen. We know our brushes like the merry men of Sherwood Forest stealing from the rich and fucking up good analogies. We can build anything we want with our ingenuity. Self-automated binary space partitions with pre-computed visibility tables. It only takes 2 to 4 hours. Even if we don't have that, we can still quickly check our view frustrums and perform dynamic occlusion through bounding volumes. Either way, brushes are the primitives of the primitive mapping community primitives. Brushes are the Kalashnikov of the game industry. Cheap, effective, easy to use. They don't jam very often. Fantastic for fucking up good analogies. We literally owe id Software epic mega games and 3D Realms to some extent so much for inadvertently providing us with line defs and sectors that eventually fueled the accidental and poorly named brush. Yep, they were never supposed to be called brushes. Everything is a lie, and this was way before the cake was a lie. Way. So with that said, this can, to some extent, explain the identity crisis some engines that are good at everything but still include brushes can have sometimes. Should I use a brush, or should I just make everything with models? Ever asked that question? I don't know. Some good examples of games that are first-person shooters but use this level design method would be Painkiller, Halo, Rage, and most recent Wolfenstein. I know there are more, but I can't think of any. Non-first-person shooters, this list gets huge fast. Pretty much every 3D game that has no concept of a brush, maybe. Well, not exactly, because there is more to the world of level design than just brushes or giant contiguous models. So that leads us right into the middle ground, the center of all things level design. The medium that can stand on its own 2 feet or sprinkle itself around with any other method as needed. These are used so often across the board that everyone from every method of design probably refers to them differently. Props, models, modules, static meshes, instances, reusable geometry, and in the case of Crytek, they decided to call them brushes, apparently to just be fucking confusing. The reason why there are so many different names for these objects is because every single level design medium converges on this point. Different mindsets and goals, different languages, different implementation, you name it, the entire world of 3D gaming converges on this medium. These props have a lot of the same technical and accessibility issues that you find when it comes to building contiguous level geometry. For starters, you have to have a 3D modeling package, which is both mentally and monetarily expensive. You have to have a solid understanding of simple collision and UV space and all of that stuff. However, there is one major difference between meshes and contiguous level design. Once created, anyone with access to a widget and a grid can use them however they want, and level design is possible with just these objects alone. Entire worlds are built this way by using separate meshes jammed together, hopefully artistically. Made a boring boxy level with brushes? Slap some meshes on it. Made a boring boxy level with a contiguous geometry? Slap some meshes on it. Made a big rolling terrain with no landmarks or cool visuals? Slap some meshes on it. Want your trees in a voxel game to not look like a bunch of wooden blocks? Slap some meshes on them. They are instances, so you can modify all of them in one shot. They are efficient to render. These are the bread and butter of everything. I mean, they really are. They have all the complex things already figured out. The only things you as the designer needs to care about is how many you use and how. And sometimes check to see if it's 20,000 polys, because artists sometimes are known to not understand why that's a problem. So now we have brushes. And I guess what? Voxels too. Wait a second. Is this guy gonna group brushes and voxels, you're thinking? I am, actually. To some extent. They are kind of brothers in arms fighting the same world-space battle. Finally, a reason for gravity. I mean, okay, voxels and brushes have one thing in common. They are both convex primitives that are combined together to create bigger things. Whenever someone touts the superiority of Unreal's concave brushes, I simply reply that all good convex primitives can become concave objects when combined. Seriously, concave brushes are completely missing the point of the medium. And here we go again, bitching about Unreal's brushes again. So why do I say that it misses the point of the medium? Voxels and brushes are Lego blocks, and we use them to build the world. They are shapes that we combine to make bigger things. Thus, they derive their strength in numbers, and efficiency in being able to lay them down as quickly as possible with as little trouble as possible is key. They are the Zerg. Seriously, the average Call of Duty level or CSGO level can have tens of thousands of these things easily. So what advantage is there to making a mutant harder to manage concave brush when it's always going to be easier to build the same shape with lots of smaller, more manageable objects? Concave brushes miss the entire point of the medium. Seriously, end of freaking story. It was nice a long time ago, maybe when everything was slower, when it actually took more time to drag out brushes. We had less options. Most tools sucked anyway, but these days it's completely pointless, especially in a post-hierarchical instancing world. So, want to make a concave shape and reuse it a bunch of times? Make it out of convex shapes, turn it into an instance, done. Not only does it accomplish the same goal, it also reaps the rewards of being an instance. Just talking about concave brushes makes me hate them more. Really. There be frustration in these parts. So, anyway, it's worth mentioning the detail about hierarchical instancing when it comes to Lego blocks versus large contiguous level designs. For starters, the ability to combine lots of smaller objects into an instance is amazing when everything in the world is made of a large number of smaller objects. Hierarchical instancing is something that is barely viewed as a mainstream feature of brush level design. I don't even think that anyone has attempted to think about this with voxels yet. Even though the technology is a dog's age old, it's way too fucking underrepresented for what it is. I still don't think people really grasp the importance of this feature, brush or voxel based level design. Hierarchical instancing is a really big deal. The world still needs to catch up to shit we already know. Now, I have been informed multiple times that this is not the case behind closed doors at various different development houses. It's really just the public mapping communities that are behind the times, or at least lacking on this front. Call of Duty 4 is ancient, and it houses one of the best examples of hierarchical instancing to date, which then means that new programmers and engineers with little game design background that want to one day design the next Radiant or Hammer killer might not know the value of this feature. They may even consider GDK to be the most up-to-date version of Radiant in existence. Which is sad. Hierarchical instancing is something devs like that need to know right from the beginning. It needs to be a core feature of your new tools. Furthermore, the feature is even more underplayed because the majority of the game industry that creates levels with contiguous level geometry and or instance meshes see the feature in a completely different light. It's almost pointless to them. It's already a fundamental aspect of the development pipeline right out of the box when you design with contiguous geometry and instance meshes. To people who build that style of design, hierarchical instancing is nothing more than some low priority feature. It's meh. It's just meh to them. When your entire world is comprised of a combination of instance meshes or smooth flowing one-shot contiguous meshes, there is almost zero need for hierarchical instancing. So last but not least is the final level design medium. I call these the hybrid crutches, as the reason for their creation is usually to supplement the weakness of brushes. Well, maybe that's not the best way to describe them. Crutches is not a good word. Think about it like taking brushes and voxels and then extending what can be done with these objects. The first example of this was Quake 3 with patches. The original screenshots of Quake 3 showed off architectural technology that would be, people would like post like so hard to do with brushes. OMG, OMG, OMG. No way. How did they do that? Patches are an example of an intentional design that proved to be extremely useful, not just for what they are, but rather for the idea that you don't have to think about everything in a square box. This is geometry that has tessellation, LODs, smoothing groups, while still being primitives that benefit from hierarchical instancing. It's like if brushes and static meshes had a baby, this would be the result. Non-instance malleable objects. This can take on so many different forms, from displacement and hammer to primitives that take on various forms, to quite literally allowing us to model meshes in the editor. All of these examples I have seen, the most extreme is COD Radiant, which gives us the power to model anything we want without any of that pesky self-important garbage like years of development into good user interfaces enjoyed with programs like Max and Maya. Yeah, it's like a modeling tool without all the stuff. While modeling in Radiant has proven to be an effective way to build, I have to say that it's far from perfect concept. Voxels are relatively new in the level design gambit, but also enjoy some of the same concepts. For starters, voxels work extremely well when you apply smoothing or displacement on them. And on top of that, voxels are also have a relatively new concept that has been recently coined: microvoxels or microvoxeling. This is not a term I have made up. It's not. As its origins come from a game called Landmark, it means building geometry smaller than a voxel in the voxel in size out of voxel level geometry. Tesseract is a 3D engine that takes this concept to a new level. With that said, I can't help but once again stress the importance of being able to seamlessly instance my work, especially in microvoxel environment. When I look at the crazy things I can potentially build with microvoxels and Tesseract, I can't help but think about being able to save these objects. Alright, so that covers terrain, contiguous level design, static meshes, brushes, and voxels. And the hybrid, the crutches. I wish I had a better name for it. It's not really so much a crutch, but the supplement of the weakness of brushes and voxels, while still maintaining their flow of design, the combining of lots of objects and making them more malleable. So the crutches, patches, and displacement and things of that nature. So that's the entire gambit. at least what I have witnessed so far. Click like and subscribe, and hope I see you again. I hope you enjoyed.
The evil that satisfies your craving. The evil that satisfies your craving.